Okay, so grade 11s, we're looking at general solutions of trigonometric functions. And we're going to do this in multiple parts just so that we get to have a break as we go along. And what we're doing for this is we're really just going to keep building on what we've been doing so far, and then we're going to extend it just that little part. So to start with, I want you to solve. Let's stay here, and I'm giving you the equation that sine, that's so tiny and squiggly. You probably want to see what I'm writing here. So what we want to solve is if I give you sine theta equals a half, and I say determine what theta is. So go for it. Pause. Well, I'm going to make it pause for you, right? And say, what are your answers for sine theta equals a half? Open-ended, fill in what you got. Okay, so now what I want you to write is just very briefly, just to write down how did you solve that? Not in detail, but what kind of tools did you use to solve that? And please, your calculator is one tool, but I mean more than just using your calculator. Okay, so you've given it some sort of go. Okay, I've got my calculator at the ready here to say, well, this is how I'd solve it. I'd say, let's find out what our two angles are. So I would have gone, okay, this is easy. My reference angle, this is important, just our reference angle is kind of informally we said shift sine of a half. And that would give me, calculator says that I'm going shift sine 0.5, or you could use the half fraction 30. So in other words, my answer is 30 degrees. Okay, and then I said, oh, well, that's just one solution, right? Aren't there more solutions? So I've got my cast diagram here for reference. And I say, well, if 30 degrees, CAST for cast, 30 degrees is one of my solutions. Sine 30 is positive, so I was in the first quadrant. Which other quadrant is sine positive? Yeah, it's in the second quadrant. So therefore I put it there and I go, well, if that bit's 30, then my other solution must have been, well, 30, I need to get to 180. So my one answer is theta equals 30 degrees. And my other answer is, well, how far away am I? 180 minus 30. So it must be 150. And we can just check that out in our calculator to go, does that make sense? What's sine of 150? Cool, it's also a half. But now we're going to take that further, because that's only if theta is between 0 and 360. I want to tell you today that there are infinitely many solutions to this problem. And our infinitely many solutions look like this. So here's our graph that we used to. There's sine theta, right? That nice squiggle. And what we asked ourselves was, if sine theta equals a half, if the y values are half, then where are solutions? Well, I'm going to just hit them here and go, there's one, look at 30 degrees. And there's our other solution. And those are our two answers. Look, no other place does this graph equal a half. That's the equation we're trying to solve. But what we did previously is that previously we were only working from 0 to 360. What happens if we added another 360 to this? So what happens if we said, hey, theta, let's actually put it next to this one and say, or what about add another 360, 390 degrees? 390 would have gone round and then round again. That's the same thing. Well, let's just check. What's on about 390? Sine 390 equals a half. So that must be a valid solution. Okay, let's try the same logic with 150. Okay, or theta equals, I'm just going to add 360. That's too much for my brain at this time of night, so I'm going to go 150 plus 390, 540. Cool, so 540 degrees is another solution. Is it? Check it out. Is sine of 540 is sine of 540, if I hit equals, is it going to give me a half? Well, it most certainly is not. Why not? What did I do? 360 plus 150. 510. I can't write. Excuse me at this late evening. So, write calculator for the check, warts and all, 510. I'm sure you're watching me going, what's he on about? Okay, so let's see. Is sine of 510 equal to a half? Sine of 510. So if we've substituted in 510 over here, we should get a half. Yes, okay, phew. So now we're sort of on track. But what happens if I say, oh, theta equals, let's just add another 360. So let's just pause and see what's going on here. Why are there so many answers? And there are two ways to look at this. The one is from our beloved cast diagram. All we're doing is we keep going around another revolution. So there, sitting here, was 30 degrees. Let's put it in pink here and said this is 30. So what happens if in this second solution we said, okay, so there's 30, but I'm going to go around another 360. So I'm at 390 degrees, which feels a bit strange on the Cartesian plane, but we've wrapped around once. We know it should be the same, because if I gave you 390, you would have reduced it to 30. If I gave you 510, you would have reduced it to 150. So we can keep going round and round again. And let's look at it on the graph because it's useful to see. To say, the sine graph doesn't just stop here. It keeps going. So if we added another 30 and we had 390, then we're going to see more solutions. So actually, there are loads of solutions. Look, there's another one there. So let's get our point here, which I've missed. There, look, 390. Here's another one here, 510. Oh, but hang on a second. We can keep doing this. So what about here? If I add another 360, so from here, look, the graph repeats itself another 360 along. So just a quick question, what is this point going to be when I click it? What is the x value of this point? 750, because you said this one here, which is 390, here's G sitting at 390. Ooh, just sneaking into the page, thank goodness. And we've added another 360 and we get to this point. So for either of these solutions, we can keep adding 360. So in other words, let's take this one here. Theta equals 30 degrees. Or we can keep adding 360 degrees. And we can keep adding it again and again and again. So in other words, we can multiply this by any number you like. Let's call it k. And it'll keep giving us more solutions. So k is any whole number, right? But wait, what happens if we go the other way? So let's just complete this and say, so, or theta equals 150. And this 30 and 150, we got there using our methods we've been using so far. And we're saying we can add in 360. Well, we can add 1 times 360 or 2 times 360. And again, k is an element of integers. Now, integers means that we can go backwards as well. So let's have a look at some other solutions. So from this first one, 30, what happens if I go backwards by 360 degrees? So I think that should give me minus 330. Now I'm not backing myself after my terrible blunder earlier. So 30 minus 360. Are you still awake? Yes, maybe that's to myself. So minus 330. So in other words, sine of minus 330, if this is an answer, we should get a half, right? Yes, yes. Should I hit pause on the ed puzzle? No. Equals a half. So in other words, we can just subtract because this would be equivalent to going, instead of going in a positive 360, we could have gone 30 and gone minus 360 and we'd be where we were before. Except we would call this minus 330. Feels a bit weird to call it minus 330, but we are sort of in the first quadrant. Maybe it's the minus something quadrant. Doesn't really matter. The point is, look at this graph. If we go negative, the graph just keeps going as well. So there was our 30 degrees. Look what happens when we go left by 360 degrees. Aren't we just where we started? So in other words, that point there, minus 330, minus 330. Can you see every 360, it's going to give us another solution. So we can go left by 360, and there's another solution. And the same applies to our other solution we got. We got this one here. We said that this point F was 150. We said that 150 was our solution. So we got two solutions between 0 and 360. Got two of those. And then from there we went, well, I could just keep going left by 360. Every time we go left by 360, we get another solution. There it is. If you could actually aim, then you get minus 210, because you could have gone 150 minus 360. So there is the crux of what we're talking about. You're going to have infinitely many solutions. So what this is called is the general solution. In other words, it's always going to hold for regardless of what theta is. We're not stuck in just our 0 to 360. We're not stuck in this little Cartesian plane, because we can keep going around again and again. So we can look at it in those terms, or we can look at it in terms of, well, this graph just keeps going forever and ever and ever and ever and ever. So if we added 5 lots of 360, 1, 2, 3, 4, 5, we'd be over there. And it would be 1,800, whatever it is, right? Because we would have just gone on one solution 30, was it 30? Must have been, right? 30 plus 5 times 360. In fact, let's just work it out for this. Would have 30 plus 5 times 360, 1,830. So that's what we're saying that point there is. I want to check it. Come on. Is it? Is it? Tell me it is. 1,830. What? Oh, right. We're on this one over here. Not that one. Which one are we on? 30 times plus 5 times 360. I'm missing the mark here. Whoopsie. I've gone 5 is all the way over here. 1,000. There we go. What's he on about, right? 1,830. I will not give up until I get that solution. I'm solution driven and want to keep learning. Okay, that's corny, right? But I think you get the point, that there are infinitely many solutions and we're going to find all of them. So previously what we did was we found 2 that were between 0 and 360. We're going to do that to start with as well. And if you need to reduce to get there, then reduce. So if you were given a second example that said, okay, sine of theta equals negative a half. Determine your two values of theta that are between 0 and 360. Okay, so you're going to have your two solutions. So you're going to go, cool, shift sine, and, well, shift, where's my shift? Shift sine of minus a half gives us minus 30. Now wait, we don't want minus 30, so I'm going to turn that into a positive and go, okay, cast diagram. Okay, so let's run through this. CAST. I was going to leave it, but it's probably worthwhile just leaving it here for reference. So we said our reference angle is, well, minus 30. So let's make 30 our reference angle. Doesn't mean that it's one of our values of theta, but sine theta is negative. So if that's 30, our two solutions must be in these two quadrants. So we're going to have one sitting over there where that's 30, one sitting there where that's 30. So our one solution is, how far is that? Well, that's going to be 180 plus another 30. So 210. Let's just check that. Always like to just check these. Partly because you see I make mistakes, so then I catch them. Cool, so minus half. So one answer is 210. This is what we've been doing already, so it's quite nice. It just draws on what we've done. And our second solution is we want to go all the way around to there. So the full thing's 360, so up to here must be 330. Let's check it. Sine of 330 minus a half. So we found our two solutions. Okay, so we had our reference angle, two solutions between 0 and 360. And then we're going to go, great stuff, plus k times 360 plus k times 360, and k is an integer. I like to do my z's, the fancy z's. Hello. K is an integer. So there are two solutions. That wasn't too bad. So everything else stays exactly the same. All you have to do is add your k times 360 and we get our general solution. The same is going to apply for cos and the same is going to apply for tan. So for those two I'm going to make two separate videos because this one's been more than long enough, right? So well done for getting through. We're 16 minutes or so in. Happy tutorialing.